I'm Dave, and when the robots take over, I'm going to reprogram them to be backing dancers. So we're going to have a little troop of robots to make all your activities both significant and sassy at the same time. So I'm going to be talking mostly about a project that I've done, which you hopefully met on the stairs as you came in, a little society of robots that talk using light. But before I do that, I want to give you a bit of background about me and a bit of thinking about robots. So I'm a little bit conflicted sometimes because I love technology and I love all the things it lets us do. But I also enjoy being a human being in the world, in all of the rich experiences that we have as people. So I'm always looking for ways where technology can kind of bridge that gap a bit, and where it can lead us into experiences that we wouldn't normally have. I like to start with this slide. This is a picture of a lake, and we all kind of know what it's like to sit by a lake on a sunny day and hear the wind and see the sunlight on the water and all that kind of stuff. The difference here, I don't know if it comes across in the slide, this red cable is part of an underwater microphone. And so I took this when I was sitting on the side of the lake with headphones in my ears, listening to what's happening inside the lake. And when you do that, you live in a totally different sound world. And you hear the waves in a different way, you hear stones grinding on the bottom, you hear lots of little things down there talking to each other and having conversations with squeaks and blips and gurgles. And it's a world that is very real for the creatures that live in it, but normally it's totally inaccessible to us. So this is a place where technology lets us kind of reach out with our senses and get inside places that we couldn't normally go. I take a lot of inspiration from science and physical phenomena. This is a desk toy that's a magnetic pendulum. And these are great fun because even though it's all very well understood physics, as soon as you get a pendulum and a few magnets, you get chaotic motion and it becomes unpredictable. And so I was fascinated with these things, and I spent quite a while trying to make simulations of them in the computer to sort of understand what they do and what they're like. But after a while that gets a bit boring and a bit unsatisfying because it's in a screen. And I like things that you can reach out and touch. So this is a project I did with Agalos Papadakis, who's a glass artist, and Owen Green, who is a sound and noise artist, where we wanted to make a big version of this. So these glass pods are about so big, and there's space, and you can move them around, and you can swing the pendulum over them. And it moves quite slowly, but it has this very gentle, chaotic motion going on. The place where technology comes in is giving us a way to pick out what's going on. So there's some sensors in there and some light, which means that the pods can sense when the pendulum's over them and they can react to that. And that kind of gives us a way to see some of the movement that's going on. It's also hooked up to a computer that's generating a soundscape. And this means that it shows you this relationship between kind of space and rhythm and pattern and melody. So you can create structures with the pods and sweep across them in different ways. And as it does that, you start to see how repetition and time and chaos come together to make something a little bit musical. So really I'm interested in the bits where digital and physical things come together and create magic. I like those moments where there's a little sense of wonderment going on. That's what I aim for. And if you do it and you're very lucky, then you get small children in leopard suits come and they play with your stuff. And I like to make things where it's okay that this person came and rolled on it and danced with it and got very physically involved. Because it's joyous and it's a different kind of learning. It's very experiential, it's very undirected, it's open-ended. But it gives people a way into science and technology that's a bit gentler and a bit more kind of humane. So, I'm supposed to be talking about robots, and if I put my academic hat on, what we like to do is as soon as someone says talk about this, we say, well, what really is this? And we like to take the definition down and give it a bit of a kicking and see where it goes. And so I went to the Oxford English Dictionary and looked up robot. And it comes from Czech, from robota, meaning forced labour or drudgery. I actually didn't learn this from the dictionary, I learned it from watching Hot Fuzz, but that's life. And they have a few different definitions for this. I'm going to take them slightly out of order. The first one is a person who acts mechanically or without emotion. And this was one of the fairly early usages that happened in the workplace to describe people who very much did what they were told. They were enslaved by the organisation in which they worked. It was quite a pejorative term. But I don't think I need to make jokes about people without emotion this morning. The next one is an intelligent artificial being made of metal and resembling a human in some way or other. And this is kind of the pictures that we expect when we talk about robots. They look a bit like people and they go around and do stuff. But this is quite a hard thing to do. This is a picture of Poppy. Poppy is an open source 3D printable humanoid robot. It has about 22 different degrees of freedom. So it's incredibly versatile. It's open source, 3D printable, still ends up costing about €8,000. And it can't really walk on its own. All the videos of it walking, there's someone holding its hands while it walks along with them. It's the cutest thing that I've seen all morning. And one of the reasons for this is walking's hard. As people, when we walk, we're in this constant state of falling from step to step. And they call that dynamic walking because we're out of balance most of the time, and our bodies react to that and arrange that our legs get into the right place. When people start doing it with robots, they couldn't do that, so they had to do static walking, where everything is in balance all of the time, and it's much slower, it takes a lot more energy. And it's only recently that people are getting their robots to understand the world well enough that they can do this kind of falling that we as humans do very naturally after a couple of years of practice. So I was looking for a slightly simpler end of it. So a machine capable of automatically carrying out complex movements, especially programmable ones. And to me this is pretty broad. This is a sewing machine. It's a cousin to the one that I have at home. And you can program it. You've got this dial where you can tell it to do lots of things. And when it's going through and it's sewing thread through a piece of material, it's incredibly dexterous. And it does really complicated things that I couldn't do by hand. And some of them are programmable to the point where you can put a different cartridge in and get it to do different kinds of stitches. But to me it doesn't quite feel like a robot. I think maybe because you have to put your foot on the go pedal and you have to steer the material through it. It doesn't seem like it's really doing it on its own. But you can go up and you can get fancy ones. These ones you can download pictures into and they then do them in embroidery. So you set it off and it goes and it does its task and it makes a thing for you. So to me that's kind of a robot, but it's not really getting at the interesting bits of robotics. A step up from this is these robot arms, these big industrial robot arms that have incredible precision and speed and grace, and they can do all sorts of different tasks. This is a still, I don't know if it comes across from Bot and Dolly doing incredible projection mapping work by having 2 robot arms holding big flat white sheets that they then project onto and move through space. If you haven't seen their videos, wonderful, go check that out. But still, this is all quite programmed. And I realised that what I'm really interested in is a sense of animacy. The moment where things start to feel a little bit like they have some life in them, like there's a spark there. This is a quote from Tim Ingold. I thoroughly recommend his book Making if you have anything to do with shaping matter in your practice. So he talks about animacy as about response and correspondence. So when you have things in the world, they respond to the forces around them, they change. And sometimes they push back. And so we have this dance as we engage with matter. We shape it and it shapes us. And we find this correspondence, and that's where we get a sense of animacy from. This is a lovely example of that. This is Theo Janssen's Strandbeest. And it uses these sails to make a correspondence between all of these mechanisms and the wind. And it goes off and it walks. And it's really hard to look at that and not have a bit of a sense of its liveness, the way these legs reach out and step from place to place. Now, it's clearly not alive. And I don't really know whether it's a robot, but it has that sense of motion, of being in the world and of responding to the things around it. So one of the places to look for response is cybernetics, which is, to me, it now sounds wonderfully retro, and I get ideas of, you know, silver helmets and wires and tubes and stuff. But this was the idea that you have some kind of sensory inputs, and you do some processing on it, and that's what drives your output. It's very kind of direct. And they did a lot of this before digital computers were commonplace. So a lot of the terminology, a lot of the thinking is around kind of flows and pressures and gradients. It's much more kind of differential equations than binary operations. It's very continuous. And so this is a piece which had some influence on the one I'm going to talk about. This is Inatovitz's sound-activated module. It's a flower that listens to ultrasound. And by people being in the space and making noise, it would sort of turn a bit and listen to them and give them a sense of attention. And it was all done with hydraulics and discrete electronics. And one of the things I love about it is that if you look underneath, you can see the hydraulic tubes that kind of give force to its movement, that let it do things. And if you look even further, this is kind of its nervous system. And I have a real sense with this that you can see its being spread out there, and you can look at the connections between the components, and you could go in there with a probe and try and sort of understand what it's doing and how it's reacting and how it's thinking. So, right, the piece I want to discuss a bit is called Lichtsuchender. It's a German word, or portmanteau, it means light seekers. We named it in German partly because it's a collaborative project with Rothio von Jungenfeld, who is half German, and partly because if you give something a German name, it immediately becomes serious art. So this is a society of cybernetic sunflowers. This is the head of one of them. I unfortunately blew this one up yesterday because I connected the wires the wrong way around, and they really don't like that. It's a thing I notice when I go from doing kind of computer-based stuff to things in the physical world. When we write code, when we do things with computers, we have all of these tools that stop us from doing stupid things. So much of programming is about stopping stupid things from happening, much more than making clever things happen. So I blew this one up, and I'll pass it around and you can all have a look. But just to kind of go over it, it's got a microprocessor on the back that is very much like what you find in an Arduino. So I've been programming them using the Arduino language. It's got 4 really bright LEDs, so it can send out beams of light. And around the side, these very delicate things are light sensors. So it's got 4 of them there and 1 in the middle. And then it's got a couple of servo motors which give it its movement. This will get resurrected at some point. It just needs new motors. So let me give that to you and pass it around. So Cybernetic we've kind of covered. Sunflowers, I'm assuming that you all know what they are. The society bit, I think I still have to get across a little. So this is a group of them. This is a very early prototype, which we showed in space. And the idea is that by making things that respond to light, that track it, and that can also produce light, you have the basis for interaction, you have the basis for communication. And they can start to notice each other, and they can start to talk amongst themselves. And as an interactive piece, I'm interested in something that people can come and play with. So if you go and shine a light at them, they'll track you, and they'll get very excited, and they'll come and play with you for a bit, until they get tired and they fall asleep. So it was done to kind of find this balance between things that have their own way of being their own lives, but also things that will step out of that and talk to people for a bit and engage. And that was kind of, that was the finished product, but actually I want to take this back a little bit and look a bit more at how it started and how it evolved. So like most of my things, it starts with a cluttered workbench covered in stuff. This is actually my workbench, although it's slightly tidier than this at the moment. And this started in a very open-ended way. I had some sensors and I had some motors, and I wanted to kind of see what I could do with them. And the bit that made it quite literally come alive for me was when I first had 4 sensors and 2 motors rigged up so it could track light. And suddenly it felt totally different. It didn't feel like a collection of components and code. It felt like a creature. And I suddenly started to read it emotionally. And there was a sense of being eager, of being excited, of being curious, or of being hyperactive and tense at different times. And it moved through a few different things that gave me different responses. I had one at one point where one of the sensors came off, and it got horribly confused, and it bashed itself to pieces against a pillar next to it. And it was heartbreaking. It was horrible. It read like, you know, a psychotic episode and mental illness and self-harm. And I know that it's just, I mean, this is held together with toothpicks and hot glue, so I know it's just stuff and a little bit of code, but it still felt like it was a real creature in pain. And so out of that, I kind of realised that I can't treat this as a project where I just come in and I do what I want to do. I have to step back a little bit, and I have to listen to what these creatures need and the way that they need to become. This was another key moment for me. This was the first time that we had a few of them in the same place. And we found that if you put them near each other, they do this kind of jerky behaviour. They react to each other. And again, I kind of know what's going on. It's a digital algorithm. It works in steps. And when they're a little bit like this, they each decide to move the other way, and then they're too far that way, so they go back like that. So you have this kind of this feedback between them. But still, when I watch it, it feels like a territorial display. It feels like, you know, it's trying to make itself big and scare the other one off. And it's a real reaction to what's happening around it. So there were these things that came up that they're really just to do with what happens when you put algorithms into the physical world, and different things come out. But it quickly became part of their being, and a thing that I wanted to encourage and see how to do more of it. So we started looking for ways that we could give them slightly richer behaviour, because the following is quite nice, but really to do a piece that takes a bit of space and that people can engage with, they need a bit more behind it. They need a slightly richer internal life. And so we looked at a few things. This is fixed action patterns. There's quite a few animals have this. This is a picture of a greyling goose, and like a lot of birds who lay their eggs on the ground, if you go and take the egg out of their nest and put it nearby, they'll come out and they'll use their beak to roll it back into the nest. Makes sense. But if you go up to it while it's doing it and you take the egg away, it'll carry on doing this behaviour even though the egg isn't there. So with a certain set of stimulus, they go into a pattern and they then do that pattern to the end, even if the world changes a bit around them and it doesn't really make sense anymore. And you see this in lots of places. Mating dances that all sorts of birds and spiders and animals have. They have these very elaborate, evolved patterns of behaviour that don't quite reference what's happening in the world around them. So this to us kind of related to some of the ways that the flowers were behaving. Another thing that we tried to bring in is some stuff from human psychology. This is Maslow's hierarchy of needs, and it's based on the idea that you need to satisfy your physiological needs before you start worrying about whether you're safe, and you need to be safe before you start worrying about love and belonging and all those things. And you gradually work your way up the pyramid till you get to self-actualization and pursuing your inner talent and creativity fulfillment, which is, I guess, what a lot of the people in this room are doing on a day-to-day basis, hopefully. Now, this, of course, has been rewritten for the internet age, because some needs are more fundamental than others. And so we put these together to give the robots a bit of a life, a bit of internal state. And so they have these different modes of being that they go through, depending on what's happening around them and where they're personally at. And they start off by sleeping. They've just got their heads down, they're slowly breathing, and they're gathering their energy. And at some point when they've got enough energy, they wake up and they want to find others to play with and talk to. So they'll send out beams of light in different directions just to see if someone responds. If they find a bright light source, then they think, right, I might have found a friend. So they track it, they become enraptured, possibly obsessed, and they follow the source of light around while sending out lots of light of their own to try and connect with something. And if that settles down, then they think they've really found a friend, someone they can talk to. And at that point they start flashing. At the moment it's just flashing. In the future that's going to be sending coded information between them. And then we can start really thinking about how communication goes through this slightly funny kind of society. And then once they've had their little chat, they get overexcited, they flash up into the sky for a bit, pure joy, and then they collapse exhausted. And it kind of goes around. And they have to go up these things one by one, but they can also fall back down. So if they're tracking a light source and it disappears, then they'll go back to sleep and wait for the next interesting thing to happen. Let's skip that, I think. One of the things that really surprised me, we really liked the idea that these things could find each other. That they would engage, they would send their beams at each other and have a good chat. And if you stand there as a human with a torch, you can get them to point in really whatever direction you want. And it's very clear that they're responding to the light and you can get them to find you. But if you put two of them tracking next to each other, they don't. And what happens is they always move towards the brightest bit of light. But if they're slightly out of alignment, like this, then the beam from the one on the left hits the centre over here, and so this one starts turning that way. And so they push each other out of alignment. And this was a real surprise, because my experience of them is embedded in the world, and I can see them, and I can see where they're pointing. So that makes it really easy for me to control them and get them pointing where I want. But their experience is totally different. because all they have is these 5 points of light, and they have to try and turn that into a picture of a world that they can engage with. So this got me thinking about really what's it like to be one of them. And I'm going to throw in a word that I really like at the moment, called Umwelt. And the idea here is what is the perceptual world that things live in. So it's about how things sense their environment and how they process it and where they get their meaning from. It's their biosemiotics. This is different for different people, and it's different for different creatures, and it's very different for the robots out there. So thinking in this way gives a way to kind of to engage and to understand what it's like to be something else or to be someone else, which gives a kind of richer quality to some of the design. One of the exciting things was they did things that I didn't expect. I expected them to do things I didn't expect, but I didn't know what those things would be. So that they have all these little bits of kind of choreography that they do kind of emergently. So you'll find that when there's a collection of them, the beam from one will graze another, and it'll wake up and it'll look around a little bit startled, and then go back to sleep. So that they nudge each other, and they start to play, and then that goes away. And there's bits where they sort of brush each other. One will be doing something, another one will send a beam, and then they'll just move in concert for a second. So it's a little bit of synchronicity in their evolving choreography. And some of them would go into these repetitive patterns where they kept trying really hard to connect, and they never quite made it. And they were always a little bit off, and one of them would give up, and the other would keep trying. Then this one would wake up, and that one would give up. And they have these little exchanges. The two that are out there spend a lot of their time with their heads bowed a little bit, not quite making contact. And it makes me think of an old couple sitting in front of the fire. And they're just sort of going along, and they're having one of those conversations where you both talk, and you don't exactly talk to each other, but somehow there's a connection there, and it's actually a conversation. So just to finish up, what did I learn from working with these? It's nice to try and sum things up. So I'm excited about the duets and trios that come out between people and matter and algorithms when you give matter the potential to move and sense and react. Then it becomes a duet, and it becomes a thing that unfolds, and you can both help each other evolve in different ways. And that makes me think of a kind of a compassionate sense of design, rather than going, right, I've got this technology, I'm going to master it, I'm going to make it do whatever I want it to do. A gentler approach to listen to it and see what avenues it leads in. And to find the animacy in things. So with robots, it's kind of clear because they move. And as soon as things move, we have a sense that they're animate, that they're doing stuff. But it's not just robots that have animacy. Any material that you work with will be always changing over time. Nothing is static like that. So that's the thing that you can work with, and it leads to a lot of richness. And the last thing is, don't build things that you can't get in a suitcase, because it makes life really hard. These we could just about fit in 2 suitcases and take on an aeroplane. But it took a lot of unpacking the bags at the airport counter and repacking them in different ways, and trying to make sure that the sharp tools didn't end up in the stuff that we were taking through as carry-on. So really the suitcase should be the maximal unit of design for a lot of things. Thanks very much for listening.
Does anyone have any, well, while you're gathering your thoughts, if you have any questions, I have a question. What's next for the
Lichtzukunde. Okay, so I get to do a shameless plug, that's great.
Yeah.
They're going to be in an exhibition for the Creativity and Cognition Conference in Glasgow in about 3 weeks' time.
every 4 weeks' time.
So they'll be shown there. I think that's the last scheduled one. I might be taking them down to London in February, but that's up in the air.
Cool. So does anyone have any questions?
Are they all programmed with the same algorithm, or do you do variations?
When we started, we were going to program them to be all slightly different. In the end, they're all the same, but that doesn't mean that they respond the same, because their physical situation is different. We're using very cheap servo motors, and a lot of them work in slightly different ways. They quite often do things like go a bit jittery, and the sensors work slightly differently. So there's a little bit of individual variation just through the way that they are in the world.
Hi there. Robots goes to this sort of level of robotics means to be somewhere between uneasy and queasy sometimes, so I'm really interested to see what sorts of things you're developing. I love your use of language right through the whole thing, calling it a society of cybernetics and flowers. It's fantastic. There's the interaction between the observer and the robot, but their interaction together also takes it to another level, which makes it a little more queasy. Also, I thought the reflection on learned patterns or patterns of behaviour was really interesting, where they carry on regardless of a change in circumstance, and mentioning how that is manifest in the sunflowers. It reminds me of I was a medic before, and it reminds me of bereavement reactions, where the dead spouse will continue actions regardless of the change in circumstances. So it's very poignant in that situation, but very real. I'm finding I was very reassured that you can blow something up like dodgy wiring. But thanks very much for reading.
Thanks. Yeah, it does make the robot uprising feel a little bit safer, doesn't it? The queasiness, I totally understand, and I know that's why these aren't humanoid robots. And I was interested in kind of what's the smallest amount of behaviour and cleverness and ability that you can give something and it feels a little bit alive. Because a lot of the sort of humanoid things and the faces with a bit of emotion on can be quite terrifying. And they give us a lot to read just because of their shapes and because we associate those shapes with people. So I really wanted to explore what very non-human, very simple robots are like.
Any questions for Dave?
Can I have comment and have a question? I find it a really fascinating talk. Thank you so much for it, and the language that you use throughout. I just wondering about sort of the findings that you've got from the end from it. Have you got plans to, or maybe you have already translated to different contexts beyond robots? Because it feels like there's so much kind of applicability around kind of compassionate design and things that you've spoken about. Where do you see that going in the future?
Yeah, I don't know. So it's stuff that's come into my practice. And I'd love to develop it further, but it's a new thing for me. So yeah, I'm very much wondering where it goes next. So yeah, don't have an answer, but I'm very interested.
Because if our things have this built into them, we perhaps throw them out, less if we felt and react to us that way.
Yeah, well, actually one of the places, in my day job I work on social machines, which this is machines in the computer science sense, so it's anything that computers do. So it's big assemblages of computers and people interacting to do things. Wikipedia is a lovely example. And it's made me think a lot of these systems, they get designed in terms of what does the person who's building the system want. And this has pushed me to think, actually, what's it like to be a person who's taking part in this kind of system? So it leads me to think of more humane ways to design human-computer interactions. That's a bit more of an answer, isn't it?